All right, so we're going to do question answer today. So let's just write down some questions that you have, then we'll go through them. So would you say 13?
Yeah, 13 on the old one.
Let's do this. So it's, well, it's all the same one, right? It's all the same one. So it's 13, 23, 29, 33. Anybody else have them? 63? Did I give you up to 63? What did I give you up to do? 73. Okay, so 63, 71, 37. I don't know if I can do all these in one class period. 53. Okay. I did. Were you here when he passed them back? Go through these, see if you see yours. All right, well, that's plenty to do. I don't know if I could do all of those in one class or not, but we'll somebody write that little list down, because I'm going to have to pull the screen, down when write them down. 13, 23, 29, 33, 63, 71, 37, 53. All right, so let's do 13. Let's just go in the order that you asked. Well, we'll just go in numerical order. There's a few out of order, but we'll go in order. All right, so 13, what is this? The cube root of negative 8 x to the 4th. Now, I was looking at some of your homeworks that I just passed back to you today. I don't know if you meant to or not, but just make sure, if I have any doubt at all, I'm going to have to mark it wrong, okay? So there should be no doubt in my mind that this is cubed and this is not like a 3 next to a square root. Everybody understand that? So make sure that if it's supposed to be cubed, it's small and it's in the little crook of this little square root thing, elbow. All right, that's what we'll call it, the elbow. All right, so make sure that it's like that. Sometimes I'm a little sloppy on these, but you cannot be, all right, because I should have no question in my mind whether it's a cube root or it's a 3 times a square root in a situation like this. Okay, this is a cube root. All right, so what I'm going to do, remember the rule where you got the stuff that's being multiplied in here, and we're going to break it up into its individual cube root. That's what I'm going to do right off the bat. Okay, so I'm going to go the cube root of negative 8, and then I'm going to go the cube root of x to the 4th. And let's start working down on these. Somebody wrote those numbers down for me, right? Okay. All right, so the cube root of negative 8. Well, we've done this so many times. You should be able to do that in your head. Somebody tell me what that is right off the bat. Boom. What's the cube root of negative 8? Negative 2. Okay? If you wanted to, I'm going to show you. Now, I got to go quick. I can't explain every little step on every one of these problems because there's so many problems to do. But I'll do this one. So what you could do is you could write it as negative 2 cubed. Why would I write it like that? It's supposed to be a 3. It looks weird. But why did I want to write it like that? Because, Aiden, what do you think? Yeah, the cube root cancels out with this cubed right here. So what are you left with? Just the negative 2. You with me on that? All right. But we've done that one so many times, you should already know what that is. Because what number times itself 3 times is negative 8? Well, negative 2 is. Yeah? All right. What about this one right here? Now, we may want to break this one down a little bit. You could do it right here in the step. You don't have to do it off to the side. Don't forget that little cubed. What you could do is this. Since you're taking the cube root of something, it would be nice, like on that 8, if you had a cube inside of there, right? So the cube root and the cube will cancel out. So how can I write x to the 4th? We did this before. Josh, what am I going to put? X cubed times x. Now, why in the world? I don't know why it keeps putting that anchor thing there. It bugs me. Sometimes it does, sometimes it doesn't. I don't know what I do to make it do that. Why in the world did I do this? Because I wanted this cube root to cancel out with this cubed. Does that make sense? Okay, that's why I wrote it like that. I could have written it x to the 2nd times x to the 2nd, right? But would that help me with the cube root? No, it wouldn't help me with the cube root. So that's why I wrote it x cubed times x. So let's see what we can do here. So again, this negative 2 is being multiplied by all this stuff. What you can do, at this point, you probably should be able to just do this in your head right here, okay? But I'm going to show you what you should be thinking. It's the cube root of x cubed, and it's the what? The cube root of of x. That's right, because there was an x left over here. See what I did? I just took this and broke it down into its individual cube roots, right? We did that step up here, right here, from here to here. All right, we're almost done. It's -2. What happens here? The cube root and the cube go, so I'm left with an x. That's just a plain old x. And this, can I simplify that at all? No. So the only way I can write it is the cube root of x, and that should be your answer. Does somebody have their finger in the back or a bookmark in the back to check the answers?
Yeah, that's correct.
Okay, I just want you to double check on me because sometimes I don't always have all the confidence in the world in me. If you do what? Yeah, you got it. Yeah. Like right here, sure, this cube root cancels out with this cube, but you got to remember, this x is also underneath of that cube root. So you have to apply that cube root to everything that's inside of there, okay? You can't just get rid of this and this, leave this an x, and then, I don't know, leave that an x. You can't do that. It's under a cube root, so you got to keep it under a cube root, okay? It's not so bad, is it? All right. What's the next one? 23? By the way, Mr. Rao's getting one of these little things so he can write on this instead of using the mouse to, so he asked me about it, and I sent him a link. So hopefully it works out for him. Yeah, I can't. I tried one time, I think, writing with that mouse. I'm like, there is no way in the world. Yeah, when I had to fill in. But I think I did that for the first day, and then the second day I brought this thing in. Okay, so it's the square root of 5 times the cube root of 9, and then that whole thing is squared. All right. Wow. Okay, now I got to think about this myself. So I put myself on the spot when I'm recording these because let's see what we can do here. I see what we can do right off the bat. Remember, everything in here is being squared. Okay, so what I'm going to do is this. I'm going to take everything in here and square it. So I'm going to take the square root of 5 and square it. I could do that in my head, but as a teacher, I'm showing you what you should be doing here. And then you're going to take this cube root of 9 and square that. So that part right there, I'm still thinking about this one. All right, let's do this. The square root and the squared, what happens there? Cancels out, so it's just a 5, right? If I take the square root, I multiply it by itself, right? That's what squaring is. Square root of 25, square root of 25 is 5. Or you can just look at it as the square root and the square cancel each other out. Now, what in the world do we do here? No, you can't square the 9. What's the answer? Is the answer left like this? Is it? Well, I should. This is a little embarrassing, but I'm going to do this. I'm just going to go. I don't know if this is going to help me or not. Oh. Does anybody have any solutions on this? Or any idea? Oops, what am I doing? Okay, so, now I'm seeing it now. So look at this. This thing is squared, correct? So what happens, these are individual square or cube roots, right? So what can I do? I can put that all under what? The same cube root. Would you agree? It's kind of like backwards of what we did on that last problem. Now I'm seeing it. So now I could go 9 times 9. Would you agree? What if I had this? What if I had this? I wanted to break that down. I could break it down to this, couldn't I? See that? So it's already broken down here. So what I can do, just to make things a little bit nicer for me, I can put all of this under one cube root. So I put the 9 times the 9 right here. Yeah? Okay. So what's 9 times 9? It's 81. I shouldn't have circled that. It looks like it's my answer. It's not really my answer, but you get the idea, right? So it would be the cube root of 81. Now, can we do the cube root of 81? Okay, you could do the factor. Like, if you don't know what it is right away, right? So you could do 81 and break that down. So what is it? Well, it's 9 times 9, and then that's 3 times 3, and that's 3 times 3. So what are we looking for? We're looking for a cube root, aren't we? All right, so I'm going to group it like this. See what we're trying to do? I'm trying to take the cube root of something. We did this twice in that other problem where we had something cubed, right? And it got rid of it, right? We were able to get rid of the cube root. So what I'm going to do is this. Keep that 5 there. I'm going to write it like this. So instead of 81, what's 81? Well, it's 3 cubed times 3. There might be a better way to do this, but this is the way that my mind was thinking at the time, okay? I might look at this later and say, oh my gosh, I should have done this or whatever. All right, but this is how I'm doing it. So, and this is a cube root. So, we did this earlier, again, in that last problem. We did one very similar to this. So, it's the cube root of 3 cubed. So, what does that become? Just a 3, right? Do I need to break this down or not? I did it in the last problem. I don't think we need to do it this time. So I could break it down into the cube root of 3 cubed, which is 3, times, what's this going to be? Just a 3? No, it's the cube root of 3. I can't simplify that at all. What can I simplify? One more thing. 5 times 3, right? So there's your 15, and there's your cube root of 3. And that should be your answer. Is that what they have? Okay. Again, there's probably some math teacher watching this and thinking, you did not go about this the best way, but that's the way that it was in my head. All right, I'm recording this, so if you need to go back and look at it, you can do that. What's the next one? 29. All right, negative. I don't know, I'm giving more credit to my videos than I probably should, thinking that a math teacher is actually watching this stuff. There's probably no way. I don't know. Some of my older videos, though, from way back. So some of my older videos from way back, I got like tens of thousands of views on a couple of them. But that was 9 years ago. All right, let's do this. What's that?
So you monetize.
No, I didn't monetize. But they do put commercials on some of my videos. So what are we going to do here? So somebody's making money. It's just not me. So I'm going to put 9 times 2. Why did I pick 9 times 2? Why didn't I pick 6 times 3? Because 6 times 3 is 18, right? But I can't take the square root of 6, and I can't take the square root of 2 or 3. So I write it so that I can do that. Now, I could have taken 6 and broken it down to 3 times 2, and that would eventually give you 9 times 3 or 2. Ugh, if I could speak, right? Anyway, 9 times 2 is 18. That's what I'm going to use here. All right, and then 2. Let's break down 8. What can we... 4 times 2, absolutely, because I can take the square root of 4. I can take the square root of 9 here. I can take the square root of 4 here. At this point, you should be able to go right to the next step in your head, but I'm going to show it to you. You could break this down so that negative, right, that negative stays with it the whole time. You could have negative 9, or negative the square root of 9 times the square root of 2 plus, see what I did? I just took this and I used that rule that says if you got two things multiplied inside a square root, you can break them down into their individual square roots. And then same thing here. But you could have gone from here to this step down here, couldn't you, in your head? Some of you could, okay? If you can't, that's fine. Write this down so that you're sure. What's this going to be? Why did I write it like this? Because I know that comes out to a nice whole number. What's that going to be? A 3. Don't forget that negative, though. And then that's going to be square root of 2. Plus 2 times, what's that? That's a 2. Why are there two 2's here? Because you got that first 2 that was in the problem. Then you got the square root of 4, which is a 2. You with me? And then square root of 2. What's this 2 times 2 going to be? Yeah. I'll just put it right here so I don't have to rewrite everything. We're almost done. Can you leave it like this? No. You got to simplify it. These are like terms, aren't they? This has a square root of 2. This has a square root of 2. It's just like it would be negative 3x plus 4x. right? You could add those together. It's the same kind of thing. So negative 3 square root of 2 plus 4 square root of 2 gives you what? 1. No, it's negative 3. 1 square root of 2, right? Negative 3 plus 4 is 1, correct? Yeah. So it's 1 square root of 2, or you can just leave it the square root of 2. And that should be your answer. Who's checking my answers? Who's the fact checker? Okay. That was an easy one, wasn't it? Compared to the other one. The other one was harder than that one. All right, give me another one. I'm on a roll. 33. Okay. Minus 2. Cube root of 54. All right. Let's take a look at this. What about this first part of this? Can I do anything with that? Can I simplify that? Cube root of 2? Nope. So there's nothing I can do with that. My guess is this will probably simplify so I can add some like terms, right? That's my guess. I haven't done the problem yet, but that's probably what I would figure. Minus, put a 2 here. Now, we got to figure out what the cube root of 54 is. Well, I'm not really sure. So off to the side, I'm going to do that little factor tree thing. That helps us out, doesn't it? And I want to group them in groups of 3s if I can. So what times what's 54? 2, right? 2 times what? 27, yeah. Break down 27. 9 times 3. Okay, and let's break down 9. That's 3, 3, 3, 2. That's 54. I didn't know that off the top of my head, but I do the little factor tree, and that's what it is. Why did I do that? What was the whole purpose in that? So I could group it in groups of 3s. Why 3s on this one? Because I'm taking the cube root of it. Make sense? All right. So, I don't know where you want to do this. Let's do it right here. So 54 is the same as what? 3 cubed times 2. Do you agree? Why did we make it 3 cubed? Because of this cube root. And that'll cancel out. That's the whole reason why we did all this stuff. All right, let's keep this the same. And sure enough, I do have the cube root of 2, don't I? So I got like terms. So I got a 2. Let's do this in our head. What's this part of it going to be right there? It's just a 3. And it's being multiplied by this 2 out here. So what does that give us? A 6. But we can't just leave this. What's this going to be? It's not just a 2. It's underneath. It's not a square root. It's a cube root, right? It's a cube root of 2. No, because this isn't cubed, right? So it only cancels out when you have something cubed. But the 2 is still underneath that cube root. Just because this cancels out here, that's why I didn't do that. That's why I didn't go bang, bang like that, all right? Because it looks like this is gone now. It's not, all right? This is just, I could have done that little intermediate step, couldn't I? I could have done this times the cube root of 2. I could have done that. But I think we've done these enough now where you don't have to do that part. You could do that in your head and skip right to this. Now let's do this. It's 5 of these. Again, because it's 2 times 3. Because this is going to be a 3. Right? Times this 2. That gives you your 6. All right? Yeah, it's not too bad. Now, this is super easy. 5 minus 6 is what? -1, or just negative the cube root of 2. You could put a 1 there if you want. Wouldn't be wrong. But that's a nicer way to write it. Feeling better about this? All right, let's do some more. Thank you. Fact checker. Was it? Let's go in order. What's the next numerical one? 37. Because I have a feeling the ones at the end might be a little bit harder. So I want to kind of go in order. 37. Another cube root. 16x to the 4th minus. And I bet you now, you might have had a question on some of these earlier, but now that we went over a couple of those, I bet you could work some of these out now. Would you agree? I think so. All right, let's figure out what we're going to do here. Cube root of 16. Does that come out even, cube root of 16? Nah, so off to the side, I'm going to put, there's the paper, okay? So off to the side, I'm going to try to figure out what the cube root of 16 is. So what am I going to do? I'm going to write 16 and then do the factor it. Okay, so what do we get? It's 8 times 2. You could go 4 times 2 if you wanted, or 4 times 4 if you wanted to. But why did I go 8 times 2? Because I'm taking the cube root. I can actually take the cube root of 8. That's one of the ones I could do in my head, right, with the cube roots. All right, there's a few I can do in my head, and that's definitely one of them. So I know what the cube root of 8 is. Or if you really wanted to, you could break this down into what? 2, 2, 2. That's the 8, isn't it? Times 2. And then you could group 3 of them, write it as 2 cubed. Okay, you could go through all that if you wanted to, but we've done this enough. I know what the cube root of 8 is, right? Okay, so, and what are we going to do with that x to the 4th? We'll work on this one in a second, okay? We've done this before already. Today we did this. So x to the 4th, what's that going to, it's going to be x, what, cubed times x, right? We did that one already. I don't want to strain your brain too much, but let's push it a little bit, all right? Let's see how much of this we can do in our head. So what do we have here? This is 8 times 2, right? So what's the cube root of 8? It's 2. And then what do we have left? Remember, it was 8 times 2, right? So what do we have? We have the cube root of what? 2, right? Let's do this part in our head right here, x to the 4th. I mean, we kind of wrote it down already. So it's x cubed times x. So it's what? I'm sorry. Stink. So it's x cubed times x. So what's the cube root of x cubed? It's x times what? The cube root of x. Now that's kind of ugly. Let's make it look a little nicer. What are we going to put together here? The 2 and the x together. And then this is both cube roots. So I could go cube root of what? 2x. Yeah? If you can't go from here to here, write all this stuff down, show every little tiny step, okay, if that helps you. And that's fine. Okay, I'm not putting you down for doing that. That's good. But eventually, you want things to go a little faster, a little more streamlined, right? So eventually, you should start trying to think in your head a little bit and go into the next step. But if that messes you up and you make a silly mistake because of that, then go ahead and write everything out. All right? Minus, now can't do anything with that, but that looks familiar, doesn't it? Again, they rigged these things, right? They didn't just happen to write this down. They did this on purpose because look, I've got 2x of these minus 1 of these. Can I take 2x minus 1 and simplify that? Can I add like terms? I really cannot add like terms, but there is something that I could do, and this is probably how the book is going to write this. Since this is in common with both of them, we just finished big old lesson on factoring, didn't we? Since it's in common with both of them, what do you think we can do with this? We can factor it out. That's right. We can factor it out. Do you see that? So if I take this and I factor this out, what am I left with? 2x. If I take this and I factor it out, I got a 1 left. Why a 1? Because really, remember, I'm dividing. When I factor it out, I'm dividing. So if I take this and divide it by this, which is the same thing, anything divided by itself is 1. That's why there's a 1 right there. My guess is this is how they write the answer. Is that true? Okay. All right. That was 37. 53. Oh, next page. Oh my goodness, that's a weird one. All right. Now this is a little different than what we've been doing so far. It's got some elements that are the same. Now here's the deal. People ask me all the time, you know, what's going to be on the quiz? Is this going to be on the quiz? John asked me about like numbers. Which ones did you ask me about? Like 69, 73, stuff like that? Is that what you asked? Oh, it's down below there. Right. It's like 75. No. If I did not assign it to you for homework, it won't be on the quiz or test. Everybody got that? All right. I hear kids talking all the time. I can't believe Mr. or Mrs. So-and-so put that on the test because we never went over it in class, blah, 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 blah. You should never, ever have to say that about me, all right? Because everything that you see on the test, you would have seen something like it on the homework, all right? It may not be the exact problem, unlike the last test, all right? That was a, what's the word? That was, yeah, I'm trying to think of that. Like when it's not the same, I don't know. Anyway, I can't think of the word. I'll think of it later. But you're not going to see that anymore, all right? But you always will see on a quiz or a test, you'll always see the problems that we have gone over in class. You'll never see anything that we've never done. Everybody got that? All right. And if you see that, if you do see that I put something on there that we never went over, then let me know. Because really, I just want to test you on the stuff that we have gone over together in class. All right, here we go. Let's add some color to this party right here. All right. So, what in the world do we have to do with this? It says to simplify this thing. Okay, it says to simplify it. So we're not really like solving for anything. We're just simplifying it. First of all, what's the problem here? Why is this not simplified? This is the part 2 to this R8. It's not because of the signs. Come on, everybody, look up here. No, it's not because we're adding them. No, the negative has nothing to do with it. It does have something to do with division, but what about the division? You can't have a what? Come on, this was our last lesson. We talked about this yesterday. That's right, you can't have a radical in the denominator. Remember that? The whole lesson yesterday was about that. Okay, I think it was. What is it? Yesterday? Yeah. Multiplied by conjugate. Was that yesterday? I think so. Yeah. All right, so that's what we're going to do right here. We have to get rid of these square roots in the denominator. We don't like that. But if you look at this, it does have a plus right here. So that means we have a certain way to get rid of this. And I'll show it. What we're going to do is we're going to multiply this by its conjugate. Do you remember that word yesterday? Should be in your notes. I wrote it down yesterday. What in the world is the conjugate? The conjugate is the same exact thing as this, except what do we change? Right, we change this addition to a subtraction. Okay, and I'll show you why once we do this. Because what's going to happen, doesn't this look like a difference of two squares? Right, it looks like the answer to a difference of two squares factoring problem, doesn't it? Because they're exactly the same thing, one's plus, one's minus. So what does that mean? It means the outside and the inside are going to add up to what? Did I teach this yesterday? Doesn't sound like it. Josh, you're right. It adds up to 0. All right, the outside and inside add up to 0. So really, all we have to do is multiply the first terms and the last terms. All right. Now, can we just multiply the bottom by this? No. What do we have to do to the top? Multiply by the same exact thing. Why are we allowed to do this? What math rule? You don't have to give me like some fancy name, but why can we do this? All in the pink right there. What's up with that? Why can we do this? What is this? All in the pink right here. What does it equal? Thank you. What is 3 over 3? It's 1. What's anything over itself? It's 1. What's this right here? It's 1. You got it? Anything over itself, even something real weird looking like that, it's equal to 1. You got it? All right, so that's why we're allowed to do it. Okay, why did we multiply by the conjugate? Because there's, let me turn back to white. Let's just see. Let's just do this. Okay? We're going to do a FOIL method, but we know multiplying by the conjugate, we don't even have to worry about multiplying the outside and the inside together. So let's just stick with the first and the last. Okay? So let's multiply those together. And really, it's not that hard. It looks hard. It looks crazy. It looks daunting, doesn't it? But it's not at all, because when I take a square root times a square root, what's going to happen to those square roots? Okay, they're basically just going to cancel out. Because watch, if I have the square root of x times the square root of x, what's that equal to? Technically, it's the square root of x squared, isn't it? What happens with the square root and the squared? they go. So look at this. This is just equal to whatever's in underneath the square root. Everybody see that? I think I said earlier, what happens when you multiply a square root times a square root? I should have said a square root that's the same thing. Okay, if multiply the same exact thing. All right, I should have said that. All right, so if I multiply this together, what do I get? What's the square root of x plus h times the square root of x plus h? It looks complicated, but it's super easy. What is it? It's just x plus h. That's it. That's all that is. Okay? Now, we just did this a second ago. Remember, the outside and inside are going to add up to 0. So I'm not even going to worry about multiplying those together. All right? Because they're going to add up to 0. Let's do the last. So the square root of x times the square root of x, it's a minus, by the way. Right? Because positive times negative is negative. The square root of x times the square root of x is, we just did it, it's just x. So that's my denominator. Now, up here, it's going to be a little complicated, a little bit, all right, for the outside and inside. So and what's this going to be right here? What happens? X minus x is what? Is 0, right? So do you mind if I do this? Would you agree? All right. So the x minus the x in the next step, it just saves me from writing another full step. All right, so that's my denominator. Now I got to find my numerator. So now I'm going to have to do a little FOIL action here. This is not a difference of two squares because they're both the same sign. So I'm going to have to do the outside and inside on this one. All right, so let's do this. This times this. We already figured what that is. Square root of x plus h times the square root of x plus h is just x plus h. Okay. Now, we got to do the outside. We got a positive times a negative, so put a minus right here. Now, if I multiply these together, let's do this off to the side so we don't have to make a big old mess inside of this. Okay, if I have the square root of x plus h times the square root of x. Okay, now let's put this in parentheses. What can I do here? I got a square root, so I could put that square root and then just put the stuff that's being multiplied inside of here. But it's very, very important that you put the x plus h in parentheses and the x right here. Does that make sense? Because what am I doing? I'm taking, it's first, outside, inside, last. So I already did the first. I got this. I'm doing the outside ones. Doing this one and this one. Multiplying those together. If I multiply them together, this is what I get. And if you wanted to, I'm not sure. Somebody take a peek in the back. Do they write x squared plus xh under a square root? Somebody take a peek in the back. Who's my fact checker? Oh, it's number 53. Do they write the square root and then x squared plus xh inside of a square root? I know I'm getting ahead of myself, but do you see it? 53. Do I have to look?
Yeah.
It's R.8. Let me see. So they do. Yes, the answer? Okay, 53. Yeah, they do. Yeah, they do that. So let's put x squared plus xh or hx. I don't know. Let's put it in alphabetical order like that. All right. Now let's do. That was the outside. Now what are we going to do? The inside. Put another minus. Okay. And let's multiply these together. Basically, it's the same exact thing, isn't it? So the square root of xh plus hx. But they have a minus in there, don't they? For 53, do they? Oops. Move that. Let's do that right there. I'm just getting this junk out of the way. Let's put this way off to the side over here. Okay. And now we're going to do the last. So what happens with the last? Negative times negative is what? Positive. And it's just square root of x times square root of x, which is just x. All right. Trying to figure out how, let me look back again at how they write the answer. R.8, 53, 2x plus h minus 2. See, they put x squared minus xh inside of there. Oh, goodness. I don't know. I'm just going to keep going here. They put a minus in here. I'm trying to figure out why, but I got all the rest. Let's add some like terms. So what do we got? We got x plus x, which is what? 2x. There's nothing I can add with the h, so I'm just going to put plus h. Now we do have this though. We have negative one of these things minus one of these things, which is going to give us minus 2 of these things. But again, the book has a minus xh. I'm going to have to look to see where I messed up. I might not take the rest of the time. What's this 10 of, right? This ends. Do they distribute the negative through here? I don't think they do. I don't think you can. I tell you what, I'm just going to leave it like that because I am not sure why they put a plus xh. Did I mess up somewhere up in here? Did I write it down correctly? 53. Yeah, x plus h minus plus. Yeah. I'm not really sure. We'll just put that on hold. I won't put that on the quiz, okay? But I'll check it when I have some time to really look over it. I just don't have time right now. We only got 5 minutes left. So if you work it out and figure out why there's a minus, you understand where I'm saying the minus? Yeah. Yeah, they have a minus right there. And I don't know what I did wrong. I'll check it because that's going to bug me all day. All right, give me one more. We can do at least one more. 63. Is that the best one to do? Yes. Oh, okay. Let's do some of those. Yeah, we haven't done one of those yet. Okay, 9/8. Tell you what, let's do an easier one. Let's put that on hold for a second. Let's do... Actually, no, they're all kind of the same. Let's just do this. Let's just do this one. And this is to the 3/2. Okay, everybody watch. So what we're going to do is this. We're going to go 9/8. Now, instead of to the 3/2, we're going to take it to the 1/2. And then we're going to take that to the what? How do I make this exponent into 3/2? I got a 1/2 right now. What's going to have to be out here? A 3. Because remember the rule for exponents? Anytime, watch, if I have x cubed to the 5th. We did that yesterday. What's that? X to the 15th, not 8th. Okay? When you take a power to another power, I remember sitting here specifically saying this yesterday. When you have a power to another power, you multiply the exponents together. It's like this. It's like having 5 sets of x cubes, right? So if I have x cubes 5 times, how many x cubes am I going to have? I multiply the 5 and the 3, right? To get to 15. Does that make sense? All right, so that's the rule. So what's up with this? What's the 1/2 power? Isn't that the same as what? What's something to the 1/2 power? So x to the 1/2 is the same as what? It's not half of it. Half of x would be this. That's not what this is. What's x to the 1/2? We learned the definition yesterday, the whole lesson yesterday. It's this, not x squared. It's the square root of x. X to the 1/2 is equal to the square root of x. That was the whole lesson yesterday. Okay? Oh, this is scaring me. Okay, so let's do this. So this fraction right here is all being taken to the 1/2 power. So technically, it's this. It's 9 to the 1/2 over what? 8 to the 1/2. Do you agree? Because everything in that fraction is being taken to the 1/2 power. We'll talk about that in a second. And then that's all cubed. We'll do the cube thing at the very end. Let's think about this. If you wanted to write it down as the square root of 9, you could. But you should recognize anything to the 1/2 power is just the square root of it. So what's the square root of 9? It's just a 3. Now, what's the square root of 8? I'll tell you what, we'll do this one off to the side. What's the square root of 8? Well, it's the square root of 4 times 2, right? Square root of 4 is 2. That 2 is still underneath the square root. So what's the square root of 8? 2 square root of 2. So that's what I'm going to put right here. 2 square root of 2. That's what the square root of 8 is. Now, all of this is to what power? Third power. Okay? Just trying to think. I'm looking at this. This first part's easy. This part right here is what I'm trying to figure out the most efficient way to do this. But let's just do this. Everything in here now is taken to the third power, right? It's cubed. So this is 3 to the third over 2 square root of 2 to the third. So what's this? What's 3 to the third? 3 cubed. It's just 27. What's this? 2 cubed. What's 2 cubed? It's 8, isn't it? Okay. Now what in the world, how do we do that? What's the square root of 2 cubed? Well, let's think about it. Square root of 2 cubed is just the square root of 2, square root of 2, square root of 2, correct? What's the square root of 2 times the square root of 2? It's 2, what? Square root of 2. So it's 8 times 2 square root of... Oh, why did I put a 3 there? Somebody stop me. Okay. Right. Because I had it over there. All right, so what can we do here? Will anything simplify? No, 16, right? Does anything go into 16 and 27? No. So 27. Now, this is not quite finished. Why are we still talking? Class not over. We're not done this problem. It's not the answer. How do I get rid of that? I don't like this because the square root of 2 is on the bottom, right? So what do I have to do? Multiply it by the square root of 2 here, square root of 2 here. So now what do we get? We get 27, the square root of 2, over 16 times 2, which is 32. Now, does anything divide into 32 and 27? No. Okay, and that should be the answer. Fact checker? Is that it? Oh, thank goodness. All right. All right, listen, don't leave. Hold on. I'll give you a choice. We can take the quiz tomorrow or Monday, but the problem is I'm not going to do another review day tomorrow. Okay, I'm going to start on section 1, on chapter 1 tomorrow. You still want it on Monday? You sure? All right, so we'll take the quiz on Monday. Is anybody opposed to that? So it's section R.8. All right.